Hello and welcome back to my channel. My name is Piyush. This is day 45 in 40 days of Kubernetes. In this video, we'll be looking into stateful set. We will not be just doing the concept, will not be just looking into the stateful set. Rather, we'll be doing the concept and then we'll be understanding it from a deep level with the help of demo. And at the end, there'll be assignment as always from CKA exam perspective and from basic understanding perspective as well if you are a beginner to stateful set. But make sure you follow this series in the same sequence because there are some prerequisites such as deployment, services, pod, and like the overall Kubernetes foundational concept that have been explained in the previous videos. So make sure you follow that and make sure you follow in the same sequence. Okay, so let me share my screen and we can just start with the walkthrough of what we'll be discussing. So in this video, as I've told you, we'll be discussing what is stateful set. That's the first part. Then how it is different than deployment or replica set, because if we already have a similar feature in Kubernetes like deployment, why do we even need a stateful set? So we'll be looking into that from a high level. Then we'll be doing a demo deployment of MongoDB application as stateful set. So we'll be deploying that, we'll be testing the changes, and we'll be looking into how it is different than if it would have been a deployment. Then we'll scale the application. We'll be scaling the stateful set with the help of kubectl commands. We'll be doing rolling updates, we'll be doing rollbacks and so on. And then we'll be looking into the assignment for day 45. I will show you the GitHub repository as well. Okay, so let's start with what exactly is stateful set, okay, and how it is different than deployment. So deployment or replica sets, these two object types or resources in Kubernetes that we have learned previously. So these are mostly for the stateless application for which we don't need to preserve the state, right? But stateful set, as the name suggests, it is mostly for the stateful application for which we need a dedicated database for which we need to have some persistent storage so that even if the application crashes or even if the pod restarts, the data remain unimpacted and it should be attached to the same pod as the identity. What I mean by that, so when you create a deployment or a replica set, okay, let's say you create a deployment with the name app. Okay, so this is the name of the deployment app. So let's say you created with 3 replicas. Okay, so the application pods will be app hyphen some random generated ID. This is for first pod 1. For pod 2, similarly, app hyphen some random ID, and pod 3 as well, app hyphen some randomly generated ID. So you don't have any control over the naming convention or the network identity of the pods controlled by deployment or replica set. Now, because they are unknown and it is some random ID with the deployment name as the prefix, it cannot be predicted. The pod name or the network identity cannot be predicted in advance. While in stateful set, each pod, okay, we'll come back to this one later, but let's talk about network identity and the name. In stateful set, let's say you create three per three replicas of the application like how we did in the deployment. In that, the pods will be created in this particular order. This is also called ordinal index, like how we have indexing in arrays or another like other data types in any programming language, starts with the 0th index and goes till n-1, where n is the number of replicas. Okay, so let's say you create a stateful set with 3 replicas. So the pod name will be app hyphen 0 because starts with 0, app hyphen 1, app hyphen 2. So this is n-1, which is 3 minus 1, 2. Okay, so in this way, the pods are created with the help of ordinal index, and it provides you a unique and stable network identity. This network identity you can predict in advance. So you can you can use the host name, like this particular pod will be exposed on this particular host name app hyphen 0. In deployment, we cannot predict it, and it the reason why it follows ordinal index is because the pods are created and deleted in the same order of their naming convention. The pod app 0 will be created first, then app 1, app 2, and so on. And when you delete the stateful set or the pods are deleted, it will be deleted in the same order. Okay, while in deployment, it all happens parallelly or rolling update fashion, but this in this stateful set it happens sequentially, one at a time, from the 0th index 0, 1, 2, and so on. Right, so that's the main difference between stateful application. Now we have done some basic groundwork of understanding it from the concept point of view. Now let's do the demo of it. Okay, so you can follow this video or you can follow the GitHub repository. In fact, let me show you the task first. So you can go to github.com and CK2024, because it was created in 2024, but it is updated with 2025 now that we are adding more videos. So don't get confused with the name or the year name. Now you have to go to resources and then uh, scroll down, day 45, StatefulSet. Okay, so it has two files as always, a readme file and a task.md. Task.md will have the assignment and this is for the solution. So task.md, if you open it, it will ask, tell you some prerequisite like you should have a working Kubernetes cluster such as Minikube, Kind, Code Cloud Sandbox, or any cloud providers manage Kubernetes service. And then it should have kubectl command line tool installed and configured, and you should have the basic understanding of Kubernetes concept, or if you are already following this playlist, that would have already been covered. Okay, so these are the tasks that we'll be following. Okay, so what I'm gonna do is I'm gonna go to this particular Kubernetes documentation, and again it also shows you like you can choose Minikube installation or any of the Kubernetes sandbox environments, right? So let's go ahead with the Code Cloud one. Okay, I'm gonna open it and it's free by the way, so don't worry about it. So you can choose the node cluster version. Let's go ahead with the latest one that is available, 1.33, and it's gonna take a few seconds and the cluster will be provisioned and then we can start our demo. So let's wait for it to provision. Okay, it's here. And now if you can just run kubectl get nodes, it shows you it has one control plane node and one worker node. Okay, let me just increase the font so that it is easily readable. Okay, now to follow the you can follow this or you can follow along the video for the assignment. So I'm gonna be creating, as I've told you, a MongoDB application. Okay, but first, before that, we need to perform some prerequisites like the environment setup. Okay, so environment is set up. We have a working environment with a couple of nodes ready. Now we also have to create a working directory on which will be um, mounting the volumes, right? So first just execute these commands and then later on I'll show you why we did that. Okay, so ssh into node 01, which is a worker node. Okay, and just run these commands to make the directory. So this will create 5 directories inside /mounts/data with the name MongoDB-0, MongoDB-1, -2, -3, and -4. From 0 to 4, because we know the name of the pods already, right? Application has not been created, still we know the name of the pod. So /mount/data, and if you're gonna do ls, so you see 5 directories have been created for you. So we'll be mounting these 5 directories as the volumes on each of the pods. Okay, so let's hit exit to come back to the main terminal. Okay, and let's clear the screen and let's verify cluster, like if all the control plane components are up, so kubectl cluster info. It says control plane is running, core DNS is running, so probably it's working fine. Okay. Now we're gonna deploy a stateful component, which is a headless service. So stateful component require a headless service. What exactly is a headless service? Headless service is which is not exposed even internally. It just um, it is available on a port. Okay. Um, so this particular service will be the front end of the stateful application. Okay, so for that, I'm just gonna go inside like any folder. You can create a new folder, or I'll just use the home directory, which is /root. So you create a file. Let's give it a name: mongo-svc.yaml. Okay, and basically it's a service, and name is mongodb-service. App label is mongodb. Cluster IP is none. So when we keep cluster IP as none, this is what makes a service a headless service. Okay, so headless service is necessary for StatefulSet. Okay, you can read it in the documentation as well. If you go down, it says begin by creating a stateful set and the service that it relies upon. Okay, so you see it created a service of nginx with cluster IP as none. Okay, and you can read about more. You can read more about a headless service, or you can just follow along for now. Okay, so let's go back. It is exposed in port 27017. Let's keep it that way, and target port is the same. Okay, so let's save this and apply the changes. kubectl apply -f mongodb-service. Okay, kubectl get svc. Okay, we see the service running, but it does not have any IP because we have not exposed it. Okay, so this is what we needed. That's the main difference between a cluster IP and a headless service. It is of type cluster IP, but cluster IP has been set as none. So it doesn't have an internal IP, it doesn't have an external IP. Okay, now that we have applied the changes, we can create a storage class. Okay, so I'm gonna open another file and let's call it sc.yaml. And a storage class is basically you can check the syntax from the Kubernetes documentation, right? Or so it's basically metadata has a name, which is the name of the storage class, and then we have a provisioner, and we set the provisioner as non-provisioner. Why? Because we want static provisioning, right? If there were a dynamic provisioning, if you were using a managed cloud Kubernetes service such as EKS, AKS, GKE, or OpenShift, anything else, then you could have used some provisioner over here like AWS EBS or Azure File Service, or we have GCP persistent disk and so on, right? But now that we are in a sandbox environment, or even if you are using a local Kubernetes installation, then you can start with setting provisioner as no provisioner, and it will basically do the static volume provisioning. Now for static volume provisioning, we also need persistent volumes to be created. Okay, so for that, so this is what we have, and we have volume binding mode as wait for first consumer, so that it will wait for the pods to be created first, so that it will bound the PV with the PVC. And you can just save this file and apply the changes. kubectl apply -f sc.yaml. Okay, now kubectl get sc, and it says the storage class has been created. There were no other storage class that were already existed, so yeah, we had to create one storage class. Then the next part is to create a persistent volume. Okay, now pause the video over here and just think about when we learned about StatefulSet, how many persistent volumes should be there, right? And like what are the different fields of it would be, right? Okay, so If you have paused the video already, thought about it, that's good. If you are not able to get it, let's follow along. So I'm just gonna create a new file, pv.yaml. I'm gonna paste the content over here. Now, as you can see, we have pv with the name pv-mongodb01, and it's mounted on the host path /mount/data mongodb-0, the path that we created on the node 01. Okay, so that's one, that's two, and if you go down, press Shift G to go at the end of the file. So we have 5 persistent volumes. Okay, so this is 4. We started from 0, 0, 1, 2, 3, 4. So there are total of 5 persistent volumes, so that each pod could have a dedicated persistent volume. Okay, so there is a one-to-one mapping between the pod and the persistent volume, and for the PVC as well, right? So that's why now we have the storage capacity 1 GB for each of those, and storage class name is MongoDB-SC. This is the same that we have created earlier. Okay, so let's save this file. Let's apply those changes. pv.yaml, and it says 5 PVs have been created. Let's see if it has been created indeed. Get PV. Okay, so you see 5 PV has been created. Status is available because we don't have any binding done yet, and all of these are 1 GB of storage, 1 GI of storage, and storage class is also the same. You can verify the storage class as well. Get SC. Okay, MongoDB-SC, which is the same. Okay, and it also has the same reclaim policy, which is retain, and basically that's it. Okay, now we have created the persistent volume as well. Now what we need to do, I think you have guessed it right. Now we need to create the stateful set so that these can be applied. Okay, so okay, so I'm gonna create a new file, call it ss.yaml, and let's paste the content over here. So what it is API version of kind of type app/v1, which is same as deployment. Kind is stateful set instead of deployment, and then we have metadata name as MongoDB. Service name is MongoDB-service, which is, I believe this is the headless service. So let me just verify it. Get SVC MongoDB-service. Yes, so it's a headless service. So the same name we have to provide over here. Okay. Now deployment can be created without the service name, because let's say we don't want to expose the deployment, but stateful set has to be backed by a headless service. So in this case, this is MongoDB-service. We are starting with 3 replicas, and this pack is same as a deployment, which we have looked into hundreds of times. So I'm not going to explain of those all those things, only the main part, which is we are using a MongoDB container with the image Mongo 4.4. Okay, that's the version which should be exposed on container port 27017, the same port on which our headless service is running, and we have a volume mount on the same directory that we have created. Okay, this is the root directory, by the way. We created inside, there were multiple folders inside this root directory. Then it has the same access mode, storage class name, storage, and so on. Okay, so let's save this file. Oh, I already saved it. Let's do a kubectl apply -f ss.yaml. It says created. Now let's do get stateful set. You see 0 are ready. Why is that so? Kubectl get pods. See, container is creating, and you see there is one container that is in creating state. So let's do a watch on it. And there are other 2 containers or other 2 pods are not even available over here. Why? Because it happens sequentially. In a deployment, it happens all at once, but over here it happens sequentially. You see, so first MongoDB 0, first pod was in container creating, then it came back to running state, which is MongoDB 0. Then it went ahead and started MongoDB 1. It went into from pending to container creating and then running. Then MongoDB 2, from pending to container creating to running. So it everything happens in the same sequential order as their ordinal index from 0, 1 and 2. Okay. So let me end this command, and if I run kubectl get pods, now I have 3 pods running. If I do kubectl get pv, I have 5 pv, but only 3 of them are bound. Okay. What all 3? PV MongoDB 0, which is pod 1. Then MongoDB 2. Oh, sorry, not this one. Then PV MongoDB 1. Okay, did it happen in the same order or no? So what all are bounded? MongoDB 1, MongoDB 3 and MongoDB 4. So these 3 are bounded with 0, 1, 2, because the PV names, the PV that we have created, like doesn't have to be with the same name, right? Only the pod name has to be from 0, 1, 2, 3. So if I do kubectl get pvc, you see they've created like PVC has been created for each of the pods. So for the first pod, it is MongoDB 0 and the pod name was MongoDB 0. For the second, MongoDB 1, MongoDB 2. So these are the 3 PVCs. Okay. And it randomly chose the available PVs. Okay. 1, 3, 4. And 2 are still pending because we have not created all the pods, or we have not utilized all the PVC. So there are 3 bounded, 2 still pending. We have 3 replicas running. Okay. If it is confusing, make sure to do the hands-on. Make sure you follow along the video, or just watch it fully and then do the hands-on by yourself. Then it will be all clear. Okay. Now we have done the verification, everything. Now let's execute let's do an exec in one of this pod, or start a MongoDB session and run some like run some commands. Okay. Like insert some dummy data inside it. So kubectl get pods. Okay, there are 3 pods as we can see. Now let's run kubectl exec -it to any of the pods. Let's go with MongoDB -0. Okay, hyphen Mongo. So Mongo is the command which will open the Mongo shell, just like we have the SQL command line, right? Similarly, it opened the Mongo shell. Now I can select a database to I'll select the default database that gets created with the Mongo. So I'll just run the command use testdb. Okay, so it will switch me to the testdb, and I'm gonna run some db inserts. Okay, so let's use this db.user.insert with the name as user1, email as this, and then name as user2, email as this. Okay, let's hit enter, and then okay, and so this is basically a select query, db.user.find. So now it has these 2 entries. Okay, user1, user2. Now let's do an exit and let's delete that pod. So we have already verified, we entered into this pod. Okay, and it is bounded to a storage, a persistent storage. Now we added some data into it, we created some dummy data. So if we delete this pod, kubectl delete pod MongoDB 0, what do you think should happen? Let's run get pod. It started again because they are all controlled by StatefulSet, just like deployment. It started the StatefulSet, started the pod again. Okay, it's running with the same name. You see, the name is same. It doesn't happen in deployment or replica set. Okay, now that the name is same, and now let's just do exec again in the same pod. Let's use testdb, and let's run the db.users.find, and you see these 2 entries are still there. We deleted the pod, it got restarted, yet it started with the same name and it still has the data because the PVC is still attached to it. You can verify that as well. kubectl get PVC, and you see it's still bounded. It did not make any changes to that because it's bounded with the identity of the pod. The pod has a unique identity, like its name, its host name, and it bounds that with the PVC. So that's the important point to remember. Okay, now the next part is to scale the stateful set. We have 3 replicas. Now let's run kubectl scale stateful set. The name of stateful set, which is MongoDB hyphen replicas equal to 5. The command is same. Like, how do we scale the deployment? Instead of deployment, we just write the stateful set, which is the resource type. Okay, so we have 3 replicas already. Let's scale it to 5 replicas. Okay, now let's run kubectl get pods hyphen watch. You see the 4th pod will be created and then the 5th pod will be created in the same sequential order. Okay, and let's wait for it to be completed. Come on, do it fast. Okay, so the 4th one is there. Oh, it created already. Yeah, so we have 3 MongoDB 3 and MongoDB 4. So kubectl get pods. We have 5 pods running. kubectl get PVC, not like this, get PVC. So we have all 5 PVCs bounded with the storage volumes. Okay, and if I do SSH to node 01 and let's go to the DataDB directory. Oh, not DataDB, what was the mount data? Inside that there were 5 directories, and let's do a find over here. You see every directory has data. So we created these directory, we created empty directory, but we also mounted these directories as the pod volume mounts to be used as the persistent storage. That's why they all have the database running over it. So that's what we wanted to see. Now you can do cleanup, or if we are using a sandbox, you can just stop the lab and it will destroy everything. But if you want to do the cleanup, the commands will be there in the GitHub repository, like kubectl delete. You delete the storage class, you delete the MongoDB service, you delete PVC, you delete PV, and so on. So that should be it. And then you delete the stateful set as well. Yeah. So that's it for this video. I hope you found it helpful. Oh, let me show you the GitHub repository as well. Or did I showed you already? I think I showed you already, but yeah. So go back over here and follow this document to perform the assignment task. This assignment will also be helpful in the CK exam. So make sure you do the hands-on. Don't just watch YouTube tutorials. Make sure you do the hands-on. Make sure you practice enough, and that will really help you. So thank you so much for watching. Thank you so much for giving your time, and I hope it was helpful, and I will see you soon with the next video. Thank you. Have a good day. Bye bye.